Good evening, everyone. I'm Jacob James.
I'm Trevor Grayson.
I'm Carissa Shipke.
And I'm Colton Snyder, and we're the data miners from South Dakota School of Mines. And we're going to talk to you today about how you can predict the attendance rates of different baseball games across the MLB.
For this project, we use a variety of open source resources, which included the original data provided by the MinneMUDAC competition, along with data found from Kaggle and baseballreference.com. For previous Minnesota weather, we used the Minnesota Department of Natural Resources, along with using MLB.com to find the data for the active rosters for the 2023 MLB season. Now, before we look at the data, we wanted to note important years in which a key event happened in the United States, which include the 9/11 attack during 2001, the stock market crash in 2008, and the COVID-19 pandemic, which happened in 2020 and 2021, in which we decided to omit the data for the 2020 and 2021 season. It's also important to note that for the 2023 MLB season, new changes are taking place, which are designed to speed up the game and create more action, which provides a good problem to predict attendance for the 2023 season.
And so before we got into pre-processing the data, we wanted to perform an exploratory data analysis to get a better idea of what the data was actually representing. And so we had several data summaries. We looked at box plots, violin plots, and correlation plots. And so here, this is kind of a summary of the attendance. It's the total attendance for all the different teams in the league for every year starting in 2000 to 2019. So as you can see, there's a downward trend starting in 2013, and we wanted to account for that with our model. And so here are box plots for all the different teams with the average attendance, and the Minnesota Twins are in the lower left-hand corner. And then to the right of them is the Montreal Expos, which have the lowest average attendance of all the different teams. And then to the right of them is the New York Yankees, which have the highest average attendance of all the teams. And then a couple over is the Philadelphia Phillies, which have the largest standard deviation. And then on the first row, there's the Boston Red Sox, which have the smallest standard deviation. So we wanted to kind of show this to highlight that all the different teams have very different attendance, and they might have different things that are affecting their attendance.
As well as looking at how the attendance differs across the different teams, we also looked at how the attendance differed across all of the other features that we were interested in. So here we have some violin plots showing kind of the distribution of attendances across the different days of the week. And from this, you can clearly see that Friday, Saturday, Sunday, those weekend games have considerably higher average attendances and are consistently higher than Monday, Tuesday, Wednesday, Thursday, those weekday games. As well as kind of that day of the week, we looked at how all of the other features correlate with attendance. So for this, we looked at each team individually, took all of their games, and saw what features had the highest correlation with attendance for each team. We took the top 3 correlations from each team, tallied up how many times each feature showed up in that top 3 most correlated features to get this plot here. From this, you can see that there's 52 different things that show up in those most correlated features, but most things kind of show up for 1, maybe 2 teams. Nothing is really showing up for a lot of teams across the entire league. So we wanted to kind of narrow down what we were really looking at to get a kind of better view for each team.
Using the correlation data, along with the fact that we're predicting the entire 82 home game season from the very beginning of the season, we were able to reduce the amount of features to 9 key features. And we want to pay particular attention to the average age of the roster, along with whether or not the game was a divisional game or not. And these 2 features tended to have the highest correlation in predicting attendance. And using these 9 features, we ran 30 separate random forests, 1 for each team to determine the feature importance. And using the results from the random forest, we were able to create the scree plot shown here. And using the scree plot, along with running our model multiple times, we were able to determine that 5 features was the best amount of features to use for our prediction model.
As well as those features that we finally determined were the most important that we actually used in our model, there were a couple other features that we looked at, but ultimately did not end up using. So from this graph here shows the locations of all of the different MLB stadiums across the country. And we're looking at how the geographic distance between the two stadiums affected the attendance rates of games. Seeing if there was a large geographic distance, if that led to a smaller attendance because the visiting fans just didn't want to make that travel. After kind of doing a lot of the work for this, we found there wasn't as much of an impact as we were expecting. And so we decided to just ultimately throw that out at the end.
So to make the actual predictions for each game in the 2023 season, we fit an ensemble model for each different team. So that means there were a total of 30 different models that we trained. And so each model reduced the number of features from 9 down to the 5 most important features for that team based on a random forest feature extraction. So these 5 features were then used to fit 4 different models: a linear regression model, random forest regression model, a support vector regression model, and an XGBoost regression model. The training errors of which were then used to create a weighted average for our total prediction of the 4 models. So the linear model works by fitting a straight line to the data as best as it can, trying to maximize the R-squared value, which is similar to the support vector regression, except SVR is more concerned with maximizing the number of points in a certain region around a line rather than fitting the line itself, which is a very different concept fundamentally from the random forest regression, which works by initializing a bunch of random decision trees that don't necessarily look at every single feature or sample, but when enough of them are averaged together, they tend to produce very good results. And that is somewhat similar to the XGBoost regression, which still works with trees, but instead of a random forest, it uses gradient boosted decision trees. And these are the results from our model looking at the mean absolute error using 5-fold cross-validation. And as you can see from the results, XGBoost and random forest tend to perform the best for this data set.
So we could look at each of the different ensemble models to find the most important features, but we'll look specifically at the twins here. And so for the twins, the most important features, the date, so how far into the season the game was played, the average age of the team. So if the twins want more people to show up to their games, they just need an older team, hire on more of those players that have been in the league longer, who've had their name out there a little longer. Also, the day of week, always important. Play more games on weekends to increase your attendance. Of course, you can't really do that. So we recommend having more promotional events on the weekdays to bring those attendance rates up to the same level as the weekend games. Also, you can see the ballpark ID was a pretty important feature for the twins. This shows that once the twins moved to their new stadium here at Target Field, they started having a higher attendance rate because fans wanted to come to the big, nice stadium. And so it was a good investment for the twins. Thank you.